All right, so the next part of this chapter that we're going to jump into is factoring. I know that you guys really missed out on this in Algebra 1, but it's something we really need to make sure we have the hang of because it's used a lot as we continue through Algebra 2 and trig and pre-calc and calculus, all things you've got coming up in your future. So I want to make sure that we get a really good grasp on this. So today we're just going to do a little bit. We're just going to practice removing the greatest common factor from a polynomial. Okay, so when we're factoring by our greatest common factor, we're looking at our polynomial. So here we have 3r plus 6. So the first thing you want to look at is these coefficients, right? So we have a 3 and a 6. So the first thing we want to do is see if those two numbers are divisible by anything, right? So we know that both of those then are going to be divisible by 3, right? So that means I'm going to write down a 3, right? Now, the first term has an r, but the second one doesn't, and so that means there's nothing else we can take out of this. So once I go through that, I put my parentheses, and so now we're going to take each of our terms and divide it by 3, what we have outside here. So 3r divided by 3 is r, and 6 divided by 3 is 2. So that means our nice factored polynomial is now 3 times r plus 2. So this is what we're looking for. Right, so basically we are learning how to undo this multiplication that we just did. All right, so let's look at example B here. So we have 12q to the third minus 24q squared. Scared. It's Halloween almost, guys. Squared. So, again, first thing we're going to do is we're going to look at our coefficients. So our numbers in front, right? So we have 12 and 24. Both of those are divisible by 12. So I'm going to write a 12 outside here. Now, we have variables with both of these, right? We have a q to the third power and a q to the second. So we have 3 here, but only 2 here. But that means we can take away at least 2, right, from each of these. So basically, you're going to look and just pick the smallest exponent. So q squared is also going to go on our outside. All right, and then that's it. We've tackled the coefficients and all of the variables we have. So we put our parentheses. Now I'm going to take 12q to the third divided by 12q squared. So 12 divided by 12 is 1. Q to the third divided by q squared. Subtract your exponents. So 3 minus 2 becomes a q to the first, or you can just write it as q. Either way, doesn't matter. Okay, then our 24 divided by 12 is 2, and the q squared and q squared cancel out. All right, so let me show you that over here. So again, the negative 24 and the 12 divide out to give us that minus 2. If you have the same exponent, they cancel out completely, because essentially it's q to the 0, and anything to the 0 power is 1, right? So those go away, which just leaves you with that negative 2. So your answer looks like this. So you can write it as 12q squared times q minus 2. So that goes there. All right, and then for example C here, sometimes you will see these two sets of parentheses that match, right? So we can right, because remember, when we have parentheses right beside something, that means we're multiplying. So we have 12x times m plus 2 minus 5 times m plus 2. So since these things are both multiplied by m plus 2, that means we can write that m plus 2 as our greatest common factor, and then it divides out, and then you're left with a 12x and a minus 5, right? Those just came from the front here, and I just brought them down. All right, so let's look at another example here. So this one's got 3 terms. We've got 2 variables we're working with, but the process is still the same. So let's look at our coefficients. We have 32, 8, and 80. So all of those are divisible by 8, right? We can't divide it by anything bigger because 8 is the smallest one we have here. So that means we're going to have an 8 on the outside of our parentheses. Now, let's look at our variables. We have a v to the 6th power, a v to the 1st, and v squared. So there's only one v here, right? So we can't take out more than that because this one only has that many. So that means we'll have a v to the 1st outside. And since this is the only thing with a u, so we can't take that u away, right? We can't pull out a u because it has to be a common factor, meaning it has to be found in every single term. Right, so that u is just going to stay. So now we're going to divide each of our terms by this 8v. So 32 divided by 8 is 4. And v to the 6th divided by v to the 1st is v to the 5th. 8 divided by 8 is 1. Right, the v's cancel out there. And then we still have that u. And then 80 divided by 8 is 10. V squared divided by v to the 1st is just v. So that would be our newly factored polynomial. Alright, and let's go ahead and do one more harder example here. It's not really harder, it's just longer. But this process stays the same. So we have 4x to the 5th y plus 20x to the 4th y z minus 24x to the 3rd y to the 3rd plus 28x to the 3rd y z. So again, step 1 is to look at those coefficients, right? So we have a 4, 20, 24, and 28. So the first thing I would do is, since 4 is my smallest number, see if all of these are divisible by 4, which they are. So that's going to be my greatest common factor. So that's going to be a 4, right? So now let's look at our variables. So we have x to the 5th, x to the 4th, x to the 3rd, and x to the 3rd. So our smallest exponent is x to the 3rd, so that's going to be what we have in common that we can pull out. Then let's look at these y's. So we have a y to the 3rd, and y. So that means we can take out at least one y. And we only have z's here, so that means we cannot take those out. So now what we're going to do is we're going to divide each term by what is in front. So negative 4 divided by 4 is a negative 1. X to the 5th divided by x to the 3rd, so 5 minus 3 is x squared. And then the y divided by y cancels out, so we're not going to have a y left with this term. Okay, moving on to our second term. 20 divided by 4 is 5. X to the 4th divided by x to the 3rd gives us x to the 1st. Y divided by y goes away completely, and then we have that z that we can just bring on down. Next, negative 24 divided by 4, negative 6. X to the 3rd divided by x to the 3rd is going to cancel out completely. If the exponents are the same, it goes away. Then y to the 3rd divided by y leaves us with a y squared because 3 minus 1 is 2. Then we have our 28 divided by 4 is 7. X to the 3rd divided by x to the 3rd goes away. Y divided by y goes away. And then we're left with a z on the end. So our final answer looks like this. All right, our Algebra 2 book doesn't have a lot of practice on these type of problems, so I am going to upload a worksheet for you guys to practice on. So make sure that you do that, and please, please, please reach out to me if you have questions. I'm more than happy to even hop on Zoom if you need some one-on-one time going over stuff with me. Just shoot me a message and let me know.